problem where we have 3 Italian books, we have 2 chemistry books, and we have 4 physics books. Okay. And I bet you're not having trouble with the first one. No restrictions means how many books are there? 9, right? 9. So it'd be 9 factorial. And if you want to remember how that works, we're just picking all of these. There's 9. Oh, let me say a couple things. These chemistry books are different chemistry books. These physics books are different physics books. They're not identical like 2 oranges or 2 bananas. Okay, so there's 9 that could go in this slot, 8 to go in this slot, 7, you get it? That's where you get 9 factorial. Last one, second one, if the chemistry books remain together. So what's happening there is that these 2, let's call 1A and 1B, are all together. So would you write that down? These slots, and then circle this. Now what we have are, instead of 9 units, we have 1, 2, 3, 4, 5, 6, 7, 8 units. And how many ways can we rearrange those 8 units? 8 factorial, right? But what's the one thing I haven't included yet? It could be BA. So there's 8 factorial for AB, and there's 8 factorial for BA. If you want to call it 2 factorial, you could. Now watch this. Let's say that this was three of them. Let's say the 3 Italian books are together. Now how many units do we have? Instead of 8, we have 1, 2, 3, 4, 5, 6, 7. This is going to be 7 factorial. And then how many ways can you rearrange 3 objects? 6, or 3 factorial. So you'd multiply by 3 factorial. What would it be if the physics books had to stay together? Well, it would be 1, 2, 3, 4, 5, 6 factorial times 4 factorial. Does that make sense? Okay. Now, if the books must stay together by subject, I like it. If the books must stay together by subject, all you're going to have here is going to be 3 factorial. But then you're going to have this 3 factorial, this 2 factorial, and this 4 factorial. This is Italian, this is chemistry, and this is physics. And this is how many groups. Does that make sense, Lauren or Myron? No? Okay. So if they're keeping the groups together, you agree with that, that there's 3 groups, there's just going to be 6 ways to rearrange those groups. Within the group, though, there's going to be 6 ways to rearrange this, 2 ways to rearrange this, 24 ways to rearrange this. So whatever ways just think of it this way. I could rearrange these 3 factorial times 2 factorial times 4 factorial, but then I could rearrange these 6 ways. So I just did the 3 factorial ways to rearrange the groups, ways to rearrange Italian, chemistry, and physics. How are we doing with number 14? Can we look at that one real quick? How many ways can 3 yellow balls, 3 red balls, 4 orange balls be rearranged in a row if they're identical in every way? So there's a total of 3, 6, 10 factorial ways to rearrange those spheres. But are there any repeating yellow ones? Yep, there's 3. So you divide by 3 factorial. How many repeating red ones are there? 3. And the repeating orange ones? Done. That's how that one works with the repeats. There's one I didn't teach you yesterday, but I want to just share with you real quick. It's loops. Is there anyone in here who has a charm bracelet? Bracelet on? We had someone who had 30 charms on her charm bracelet first hour. That was cool. But let's say I had A, B, C, and I put them on a charm bracelet. How many ways can I rearrange those? Well, this looks pretty hard. But watch what happens if I go A, C, B, B, C, A, B, A, C, C, A, B, C, B, A. And think of those on a charm bracelet. And how many of those are going to be duplicates? If you can swing those charms around, are there any duplicates here? Like, let's make a little heart out of this one. Oh. And then, are there any others that are A, B, C? Just you might have to move the charms around. Yeah, this last one, B, C, A. Yeah, because you could swing this around and it's A, B, C, so that's the same. Any other ones? C, A, B. Yeah. Okay. And you would agree that these other ones are different, but are you noticing that ACB is going to be the same as BAC? Because you could bring the C around and the A around, and you'd be good. So yeah, that would be the same. And is this the same as ACB? Yep. So what this means is that we started with 3 different objects, and we ended up with 2 different arrangements. And if you went 3 minus 1 factorial, you would get it. So in a circle, you just take the total minus 1 factorial, and you'll get it. This works with 2. Okay, if you had AB and you had BA. Okay, how many ways could you rearrange these? I mean, are these the same arrangement if you swung this A around? Yeah. So is 2 minus 1 factorial equal to number of arrangements? Yeah. If you had 4, it would be 3 factorial. If you had 20 charms and you put those on, that would be 20 factorial. I'm sorry, 20 minus 1 factorial, or 19 factorial. I'm going to bring this up just to give you a little background information. Have you ever heard of the word clasp? On a charm bracelet, what's a clasp? As you put things together and take it off, right? If there's a clasp to it here, can we swing this B around? No. And so if there's a clasp, it's just n factorial, or in this case, 20 factorial. If there's no clasp, it's going to be n minus 1 factorial. It's just a verbiage thing. The whole idea is if you have a continuance of possibilities on the ring, it's like having one less object because you can always move them together. So, and clasp means you can't swing them around.